हेलो स्टूडेंट्स, एक क्वेश्चन देखते हैं. देखिए राइट, इस क्वेश्चन में क्या है, अराउंड बॉडी ऑफ रेडियस दिया है, मास दिया है, मोमेंट ऑफ इनर्शिया दिया है, रोल्स डाउन विदाउट स्लिपिंग एन इंक्लाइन प्लेन angle theta, right? So let us take this is angle theta here. So okay, so this is the inclined plane, this is angle theta, and round body is rolling without slipping. Mass everything is given. So let us take how many forces will act here. See right, in this direction first it will act mg sin theta, right, and here another component will act, that is mg cos theta. Okay, and at the point here one normal will act, and here in this direction some friction will act. So all these forces are acting. Now we'll see in this direction all the forces must be balanced. So I can say here N must be equal to mg cos theta. Okay, now you can apply, right, in this direction mass into acceleration of center of mass. So m into acceleration of center of mass, right, because this will accelerate in this direction. So mg sin theta must be greater than f, that is friction force. So mass into acceleration of center of mass, that must be equal to mg sin theta minus f. So let us call this is equation 2 here. Now I can use the torque equation. So Fr will be the torque is equal to I into alpha. Let us call this is equation 3. Okay. Okay, now we know it is moving without slipping. So I can say here acceleration of center of mass must be equal to alpha r. So what is the acceleration of center of mass? We can say here this will become, right, m will get cancel out and it will become g sin theta minus f upon m. And alpha, you can say what is the value of alpha, that is fr upon I. So alpha I will get here fr upon I. This is the value of alpha, and r is once again, so fr square. Okay, so now I can take here, this will become g sin theta. I can take this f by m this side, and since f will come outside, so I can say here r square upon I plus 1 upon m. So what is the value of f from here you will get? See right, I can see like this here, g sin theta is equal to f, that becomes mi. Okay, mass I multiplied here, so this will become mr square, and if I multiply here with I, so this becomes I. M here multiplied, so m here, mr square, I multiplied here, I multiplied here, so now you are getting this. So I can see here what is the value of f. I can take, so this will become m I g sin theta upon mr square upon I. So this is the value of f you are getting. So let us call this is equation 4. All right, see right. So now I need to find the acceleration of center of mass. So acceleration of center of mass is how much? C, right? Acceleration of center of mass, right, that will be equal to g sin theta, right, g sin theta minus f upon m. So this becomes g sin theta minus f upon m. So I can take this m this side, so it will become f upon m. So what I will get here, this becomes I g sin theta, right, upon I plus mr square. So this becomes I plus m r square. See right. So this you got. So I can take here g sin theta common. So I will get here, right, this f upon m I am using from equation 4. You mind it, right? I have taken this m this side, so f upon m, and this quantity will be f upon m. Okay, by using equation 4, right? Now g sin theta it can be taken outside, so I have taken it outside. So g sin theta. So this will be common, and this will become 1 minus I upon I plus mr square. Okay, so this becomes g sin theta. Okay, and now this will become I plus mr square. Okay, and upside it will become mr square. So once again mr square I can take in denominator, so this will become g sin theta upon, if you take this denominator, so this will become 1 upon I divided by mr square plus 1. So this will be the answer, right? Okay students, I hope you understood this question.